Coffee. Need coffee. Everyone needs coffee. So it's been about 4 weeks since I uploaded my last video where I showed you how to set up HashiCorp Vault. And in that video, we configured HashiCorp Vault to be our certificate authority for our home lab. And specifically, we set up a root and an intermediate certificate authority. So I wanted to kind of build on that because in that video, we issued our certificates once everything was configured. We had issued our certificates manually. So we went into the UI, we clicked issue certificate, we provided all the information. But in this video, I'm going to show you how to automate that process. So if you're like me, in my home lab, I'm constantly deploying applications and tearing them down. And every time I build a new one, I need a certificate. And so going into the UI and clicking and issuing a certificate and then bringing it over to the machine that way, that's a waste of time. So what we're going to do is I'm going to show you real quick how to automate that process using something called the AppRole auth method in Vault. So real quick, here's an example of what that's going to look like when we're done. I'm simply going to run a script and it's going to output my certificates for me onto the machine. And so the goal here is that every time we deploy something like a VM or a container, we automatically ask for the secret, or in our case, the TLS certificate. Before we jump into the video, thank you to my Patreon subscribers here on the screen. I do this on the side in addition to my full-time job, so any of your support really does help. Thank you. If you haven't already, go ahead and subscribe to me on Patreon if you'd like to support the channel and see more content. And just like the first video where we configured HashiCorp Vault to be our home lab certificate authority, everything we're going to go over in this video will be in a PDF document format that you can access for one-time purchase over on my Patreon shop. Link in the description. Some of you more familiar with this topic may be ready to point out that there is already a protocol to help the automatic issuance and rotation of certificates called the ACME, or Automatic Certificate Management Environment Protocol. While Vault does support the use of the ACME protocol, we will not be going over that in this video. So let me give you a real quick overview on what the actual outcome of today's video is going to be. So I have a VM here called monitor.lab, and it runs my monitoring stack, Prometheus, Grafana, InfluxDB. And I have a bash script here called getcerts.shell. And the goal is when this VM starts initially every time, this script is already pre-installed and it's going to run. I'll go ahead and I'll run this, and then you see that nothing happened, but now I have monitor.lab.com, monitor.lab.com, key, cert.json, and cert. And these are my TLS certificates that I would then move into the required locations for the application to use them. And so that's what we're going over in this video. So we are going to be using an authentication method in Vault called AppRole, and this is essentially designed to allow a remote machine or application, not a human, to request certificates. So kind of like when you onboard a new person into your company, you give them a username and password, and then they can go and retrieve certificates and secrets and whatever they need. Well, when we onboard a new application, sometimes that application needs access to secrets, in our case, TLS certificates. And so we're going to give the app a username and password so that it can then use that to request a token, which it can use to get certificates and secrets. So we enable the AppRole auth method in Vault. We create a policy in Vault and we assign it to a role, which is attached to the auth method. We get a role ID and a secret ID. And so from that point, we're giving the role ID, which is equivalent to a username, and the secret ID, which is equivalent to a password, to the application, in our case, my virtual machine, right? And then in that example I showed you, my virtual machine is using it in a script to then request a token from Vault. So it's authenticating, it's getting a token, and that token is allowed to request TLS certificates. And so I'm using that token to issue TLS certificates. Now, those of you more experienced with this kind of thing, you're probably already noticing the big issue here, the big flaw, is that the secret ID is essentially equivalent to a password. I have to provide that manually to the application. So if I want the secret ID to constantly be expiring like every 24 hours, right? If I don't want it to be a long-lived secret, I essentially would have to, as the admin, keep going back and updating whatever location the secret ID exists in. And so we need a secret 0. We always need a secret 0. In our case, that's secret ID. But in order to get a secret ID, you need a Vault token. So you need a Vault token to get a secret ID to get a Vault token. And there is a way around that, and that is by using response wrapping. So I'll scroll down here. You can response wrap the secret ID. So you have basically like a third entity between the admin and the application that handles the secret ID issuance. And we're not going to go over that in this video because that is beyond the scope of this video, and I don't want to sit here for 3 hours. So we are only going to go over this workflow right here for now in this video, and we are going to manually deliver our RoleID and SecretID to our VM, which means we are going to make it a long-lived secret. So in order to get started, you will need Vault installed and running in your environment. Now, if you followed along with the first video, I'll put it somewhere here on the screen and a link in the description. We set up Vault and configured our certificate authorities together. And so that is the prerequisite. You will need Vault set up and a certificate authority configured using a PKI engine of some sort. I have a root and an intermediate certificate authority. You will also need a role configured in there that you can issue certificates from. And again, it's all in that video. And in addition, you will also need a Vault command line interface running somewhere that can reach your Vault server. So this can be any computer in your lab. It can be any computer in your house, as long as you have Vault command line interface installed and it can reach your Vault server, you're good. And then if you're following along with this video frame for frame, then you will want a VM to run these commands on to follow along. Now, I am using a Proxmox LXC container, but for all intents and purposes, it is a VM. So any computer where you can run the Vault command means you have the Vault command line interface set up. All right, so let's get started. So pick a place in your house. I don't care where. A computer that has the Vault command line interface installed. It takes 2 seconds to install the Vault command line interface. I will put a link in the description. But once you have it installed, you should be able to run Vault. And I'm actually going to start fresh. So I have my LXC container here on Proxmox, or a VM, which is the equivalent to a VM right now. And I'm just going to go ahead and delete everything in here so we can start from scratch. Okay, so as the admin somewhere on my network, right, I'm going to run, I first need to connect to Vault. So I'm going to set an environment variable, Vault address equals, and it's going to be HTTPS vault.lab.com port 8200. Right, and so I'm telling the Vault command line interface how to connect to my Vault server. Side note, you will get an error about TLS certificates X509 if you don't have your Vault certificate authority certificate installed in your wherever you're running Vault command line from. And if you don't have a certificate, and if you do want to bypass those TLS errors, you can run like the, I think it's the, let me see real quick, Vault read-help -TLS. There is a -TLS-skip-verify to disable verification of TLS certificates. So that should help you get around those errors if you're too lazy to configure that. And then I also need to provide an authentication method. So if you followed along with the last video, we had configured Vault and we didn't configure any other users. So the only user was the root user, and we had a root token. And so that's actually what I'm going to set. So I'm going to do Vault_token as the environment variable, and I'm going to provide my Vault token. And so now I should be able to run Vault status, and I'm connected to my Vault server. And just to make sure I have the right permissions, as root, I'll do Vault secrets list. And then let's just run Vault kv get, kv argo admin, the path to my argo cd, admin username and password, and yeah, I can retrieve those. So I'm pretty sure I'm authenticated as the correct Vault user that I want to be, aka root. So now that we're connected to our Vault server and authenticated, we need to enable the AppRole auth method. So we can do this through the CLI, and we can also do this through the UI. So if you're interested in doing this through the UI, you come into your Vault server and you go to access, and if you go to enable new method here, you would just choose AppRole, and you would give it a name, and you can configure these if you want to, but we're not going to configure any of these in this video. And then it would end up mounted under access like I have here, AppRole. And then to do this in the CLI, you would just do Vault auth enable AppRole. And then because I already have it configured, you know, it's telling me that the path called AppRole is already in use. So if I were to like go disable this and then go ahead and run it, right? Success, enabled AppRole auth method at AppRole. So if you did run into this error and you wanted more than one AppRole mount configured, authentication mount configured, you would have to provide the -path equals and then the name of the path that you would like AppRole to be mounted at in Vault. So I'll just call it AppRole2, And so now if I go into Vault and I go to authentication methods, and I'll just reload my page here, and I have to log in apparently. Sign in. I can now see that, I have two AppRole authentication methods mounted, AppRole and AppRole 2. The next step is we have to create a role and attach that role to the AppRole auth method. And that role is what our machines or applications will use to when they authenticate to our AppRole auth method. And that role has policies attached. So we also have to create policies, and policies describe what someone or something can or can't do. And then we attach the policy to the role, and that's how we define the permissions of the role. Yeah. The first thing you need to do is you need to figure out the name of your intermediate certificate authority if you're using one, or just your certificate authority if you're just using a root. Figure out the name of that path. So mine is intermediate_CA. This is the one we had configured in the last video. Again, link in the description, video somewhere over here. So intermediate CA, cool. I've noted that, I've written it down, I know what it is. So we can create our policy first. So we can do that through the UI if we want, right? So I've already gone ahead and configured this. So you can hit create ACL policy, name it wherever you want, and put your policy in here. But I've already created it. I called it issue PKI. And here are the permissions. So on my intermediate certificate authority path, I am allowing anybody who has a role with this policy attached to create and update certificates. I am also allowing them to read from this path and read from this path. So I'll put a link to this policy in the description, or maybe I'll just put the policy in the description. I don't know yet. So you would just copy that from wherever I provide it, go over to policies, create ACL policy, give it a name, paste it, create policy. Alternatively, if you did not want to do that in UI, you can create policies through the CLI. You can do everything we're doing in the UI through the CLI. So to do that, we're just going to create a file, and I'm going to name it pki-policy.hcl for HashiCorp configuration language. And in here, I'm going to go ahead and paste my policy, and I'm going to save that. And so now I have my policy file. The next thing we need to do is we need to actually apply this policy in Vault. So let's say Vault policy write PKI policy CLI example. So that's the name of the policy, and then what policy would I like to create from. This one, success, uploaded policy. And so now if I go into the UI and I refresh this policies page, and I gotta sign in again, here's that policy we created with the CLI. Okay, now we need to create a role so we can attach the policy to the role. And the role is what we will be assigned, or our application or VM will be assigned when it authenticates the Vault. So we're going to do Vault write auth/AppRole. And this is AppRole. This is the path to your AppRole authentication method. So in my Vault, right, I've named my, where's access, authentication method. The path to AppRole is AppRole/, and so that is what I'm going to provide here. If you had named this something like VM AppRole, then you would provide that path here. So just don't, if you name your path something different as you're mounting the auth method, just keep that in mind. And then it's going to be role, and then the name of the role that we want to create. So I'm going to call mine VM-role, and now we have to provide some parameters here. So I'm going to move to the next line. So let's provide secret_ID_TTL equals, and then a time limit. So basically when we request a secret ID from Vault initially, when we need that role ID and secret ID, this is how long that secret ID is going to be good for. So because we're not implementing a kind of like third-party trusted entity to keep renewing and getting this secret ID for us, I'm going to make this long-lived. So I'm just going to do 180 days. So that's about a half a year, 6 months. And then I'm going to move to the next line. Next, we're going to do token_num_uses equals 10. So basically, once we request a token with this secret ID, how many times are we going to be able to use it? And the total will be 10 for us. And I'm going to move to the next line. Next is going to be token_TTL equals, and this is how long the token that's issued is good for. So typically you want this to be good for a very short period of time. And that's the whole purpose of using AppRole. If we had a long-lived token, we would have no reason to keep retrieving one. And this is for security purposes. If somebody gets your token, It's only good for 1 hour. I'm going to move to the next line. Token underscore max underscore TTL equals, I'm going to set this to 10 hours. So Vault has the capability for you to renew tokens in Vault if you so wish. So if we keep renewing it, so if we keep renewing it before every hour, we can renew it up to a maximum of 10 hours before it expires. And then I'll move to the next line. And finally, what policies do we want to apply to this role? And I had named my policy. Let's go back here. Policies, issue PKI. And so in parentheses, as a string, issue PKI, the name of the policy I want to attach to this role. Then I'm going to hit enter. Success. Data has been written to auth AppRole role VM role. So I now have a role attached to my auth method AppRole with a policy attached. So the next step is now to get a role ID and a secret ID. So the role ID is the ID of this role that we had just created. So that's never going to change unless we're creating different roles or what have you. So we're going to go ahead and we're going to read the role ID. So we're going to do vault read auth slash AppRole slash role. And again, AppRole is the path where your AppRole auth method is mounted. If you named it something different than AppRole, make sure you change this to match your path. And then we're going to do VM-role because that's the name of the role that we created. And then role underscore ID. Role dash ID. Sorry. And this is the role ID. So go ahead and copy this. Make sure you save it somewhere so you don't have to keep retrieving it. And then we're also going to go ahead and get the secret ID, which is equivalent to the password. So we're going to do vault write this time -f auth AppRole, again, making sure the path matches our AppRole auth method, VM-role, and secret ID. Oops, I forgot the role here. Okay, now I get a secret ID back. And we can see that the TTL is 768 hours. And that matches, I believe, what did we configure up here? 180 days? No, it does not. Oh, you know what? I think Vault has a default secret TTL. Yeah, so the reason that is happening is because the Vault So the reason that's happening is because the Vault auth method, the default TTL for any secrets generated by that is 32 days or 768 hours, which I can see that my TTL is set for. We can override this in Vault, but that is actually beyond the scope of this video. I believe there's you can tune the auth mount itself, but there's another settings within the actual Vault server settings you have to configure to override that. So we're just going to go with that now. So my secret ID is good for 768 hours or 32 days. So I'm going to go ahead and copy that and put it somewhere safe along with my role ID. So now you've got your role ID and your secret ID. You now have to give them both to your execution environment. What I mean by execution environment is whatever machine or environment where you're going to be running the actions to connect to Vault with the role ID and the secret ID to return a token and then take that token to issue a certificate, right? So an execution environment could be something like a CI/CD pipeline, such as GitHub Actions, in which you use maybe the Vault GitHub action. I think there's an example here for AppRole, right? You give, in GitHub Actions, if you're familiar with it, you can configure secrets, right? So you would put your role ID and your secret ID in your GitHub Actions secrets, and then use this action to then retrieve those and connect to Vault, and that would return a token, which you would then use to connect to Vault and issue your certificates in your. So that's just one example of doing that with a pipeline. If you were using something like Jenkins or Azure DevOps, you wouldn't have these actions. You would have to install Vault and then somehow pass in these secrets, the role ID and secret ID, right? If you're using like Docker containers, any kind of containers, right, you would have to pass those environment variables or those secrets into that container. And maybe they would run a script on startup that used the role ID and the secret ID. But in our case, our execution environment is my LXC container here, or my VM for all intents and purposes of this video. So typically with like virtual machines, something like this, you would have some kind of startup script or action that took place that either already contained your role ID and secret ID, which isn't the most secure, or fetched it upon boot up somehow. And then the script would use that to authenticate the vault, get the token, and then issue the TLS certificates. I don't have that whole process set up to go ahead and bake an image, so I'm just going to show you what you would do initially, right? So we're going to create a script together, provide the role ID and the secret ID, similar to the one we set up at I showed you at the beginning of the video, and use it to issue our certificates. So I'm going to create a bash script here. We're going to call it getCerts.shell. Then I'm going to go ahead and paste the contents that I already had on my board here, and I'm not sure why that happened. Okay, so I fixed the script. So what's going on here? So this is a bash script, and we've got some variables we're setting. So what's the vault address, so that our vault command line interface on this VM that's being used by the script, right here, we run vault write to get our secret ID. We run vault write auth with our role ID and our secret ID to get our token. And then we also run vault write to issue our TLS certificate. And in order to do that, we need the address of our vault server. So I'm going to go ahead and set mine to HTTPS vault.lab.com. What's the role ID? So hopefully you saved that from earlier. I know I did, so I'm going to paste the role ID. What's the secret ID? And again, we saved that earlier in the video. The common name. So the name of my host name here, my server, is monitor, and I'm in the domain lab.com. So this is the common name of your server or application or website that you want to resolve with this TLS certificate. So monitor.lab.com will be mine. The PKI engine path. So this has to match the path to your PKI engine in Vault, which would be either your root certificate authority or your intermediate certificate authority. If you followed along with me in the first video, it would be the intermediate certificate authority that we're using. And because in there we have a role configured. And speaking of that role, so mine's lab-dot-com. That's the next variable here. What role, when I request a certificate, am I going to use? Well, I'm going to use lab-dot-com. And then we're going to export the Vault address using this script. We're going to use Vault to log in using the AppRole authentication method. We are going to use our role ID and our secret ID. We're going to format the output, the response, in JSON. We're going to use JQ. And that reminds me, make sure you have JQ installed to execute this script. Please install JQ. And that's going to return just our token. And then we're going to set the environment variable for Vault token, because right now my Vault token is set as the root token. I'm going to get a brand new one when I issue this command, and that's the token I want to use to issue the certificate. Then we're going to request the certificate. So we're going to use Vault CLI at our intermediate certificate authority path to issue using the role that we've defined. So up here where it says role name, to get a certificate with this common name. And how long is that certificate going to be good for? So as it stands right now, this is 24 hours. Maybe I want it to be 365 days, right? And I'm going to output the response in a JSON format into a file called cert.json. And then I'm going to parse that cert.json file using JQ to get the certificate, the private key, and the issuing CA certificate, and output them into their respective files. So I'm going to go ahead and save that. And then I'm going to make sure this is executable. And then I'm going to go ahead and execute it. All right, no response. That's what I expect. But now I should have 4 files. So I have certs.json, and this should have been all of the certificates that were output. Yep, just the way I expect it. And then we have ca.cert, so this is the issuing CA. So let's make sure that got output properly. It looks like it did. And then let's check monitor.lab.com.crt. That looks good. And let's check monitor.lab.com.key. Begin RSA private key. Okay, so everything looks good. Looks like we successfully issued our certificates. Now, at any point I want, if I need a new certificate on this VM, I can just go ahead and rerun this script. and it would issue me a brand new certificate. And if we wanted to verify these certificates, right, to make sure that, you know, they were valid and set for what we expect them to be for, we could run OpenSSL, assuming you have OpenSSL installed, x509-in, and then the certificate that we want to check. So let's do this one. We're going to do no out and dates. Sorry, dash dates. Right? Okay, so this certificate is not good before today's date, June 25th, and not good after June 25th of 2025. So a whole 365 days, which does match the TTL that we have configured here. So then obviously, now that you've got the certificates on the machine, depending on the application you're using, you're going to want an additional script or some kind of configuration management tool that then takes these certificates and moves them into the proper locations for your application to take advantage of, right? So you may choose to extend this script right here. So like if you have an application and you know where it reads the certificates and the private key from, maybe like /opt Grafana or something, right? You could do something like copy parenthesis common name dot cert to opt, I don't know, Grafana SSL cert, right? And then you would just do that again for the private key and you just do whatever you need to do, because after these are run, the expectation is that the certificates are now on the machine. And then if you wanted to rerun, you know, get certs periodically, automatically, and rotate them, you know, you would create some kind of script. You would create some kind of cron job to run this script, put the certificates in place, restart the application, what have you. So that's it for this video. Hopefully it was helpful. Like I said, there are some glaring issues with this method of delivering the AppRole and SecretID to the VM or application. And those were outside the scope of this video. And there is such thing as an Acme protocol automatic certificate management environment that we could have used to automatically rotate their certificates, but again, because Vault does support that. But again, that was out of the scope of this video. Subscribe on Patreon, even if it's free. Any support helps. Thank you.